So, welcome to the first installment of An Engineer Reacts. I can say that now. I graduated. Yay! This is a video from Kev Does, and Kev is actually a biker. So, if we take a quick gander at his channel, you see that most of his content is actually biking related. Biking in different locations, particularly the Dominican Republic. And he actually made this video not too long ago where he 3D prints a copy of a very expensive Canon Aero bike, or Canyon Aero bike. These are carbon fiber. Thanks, Wills. Yeah, feels really good to be graduate. Woo! But this is a $6,500 bike, and he's dived right into the deep end. Kev has not done any CAD, any 3D printing, or any design work along these veins whatsoever. So he's given himself the admittedly self-imposed YouTuber deadline of being able to get this done in just over a week. But this guy just exudes enthusiasm and charisma, and I really just wanted to kind of take a look at his process through this, and then talk about things that I've learned that could help Kev Does do better if he does a version 2 of this bike. Nor do I. Spoiler alert, it's not, but I appreciate the enthusiasm. The optimism's great. Oh no, you can't hear the desktop audio again? Okay, hold on. Let me fix this.
Some great tutorials, and after about 6 hours I used my new 3D modeling powers to follow along with his tutorial and modified it to look a little more.
Alright, Wills, tell me you heard that snippet there. Talking about Too Tall Toby. Okay, alright.
More like the Canyon Aero handlebar.
Okay,
it's not perfect. I don't know how to fix these little weird twisty lines right now, but we got something.
Okay, so sorry, let me go back there. Too Tall Toby is he's an on-shape expert. He's really good, and he has a great list of videos if you're trying to teach yourself how to use on-shape. So that would probably be one of the first resources that I would send someone to if they had not done any CAD work in the past. So good on you, Kev, for finding that on your own. There are a couple other resources that I would send you to as well. One of them is... let's see, let me do this on another window so I'm not flashing my YouTube history in front of everybody quite so blatantly. Teaching Tech and Maker's Muse. So these are two of my favorite creators for CAD, 3D modeling, and anything like that. Teaching Tech is going to be more focused on 3D printing, but he does show all kinds of tips and tricks on how to CAD specifically in Onshape. Let's see. I want to find a recent video of his. Yeah, how to design and 3D print custom vacuum cleaner nozzles. Great video on doing lofts and a lot of the basic functions of Onshape to make very useful attachments for a vacuum. The other one is Maker's Muse, and the videos that you'll find on his channel that are CAD related are going to be more geared towards mechanisms. So gears, this one on a Scotch yoke was really interesting. So two fantastic creators, highly recommend them. Great resources if you're trying to learn the basics of CAD. Now what you ran into with this section here,
Who had some great tutorials, and after about 6 hours I used my new 3D modeling powers to follow along with his tutorial and modified it to look a little more like the Canyon arrowed handlebar. And okay, it's not perfect, I don't know.
Okay, so these kind of ugly lines here, that's just because it didn't know how to make that loft the way that you were telling it to. So we can pull up Onshape and use my personal account, not my work account. And let's see, can I find one right off the bat that I know I used a loft in? Probably not. So let's just create a very basic one then. So two basic sketches, about as basic as they come, right? What you're doing is you're doing a loft between two profiles. And in this case, it did work out somewhat reasonably, but anytime there's a mismatch between the number of vertices between any two profiles, Onshape isn't always going to know what to do there. So you have this option here called connections, and these purple lines are the connections that currently exist, and it's actually done a pretty good job. But let's say, for instance, that I actually want this line to go more along the contour, then we can actually adjust it like so. So if we go back to yours, Kev, you have a vertex here and here, and then you have a curve back here, but you also have two vertices here and then on the other side of the semicircle. And you're bringing that down to a similar shape, but it is a little different. And so that mismatch is what's causing this error to pop up. I bet, though, if you pull up your document, go to this loft feature and do the connections, you can reroute those and be able to get the shape that you're looking for.
I don't know how to fix these little weird twisty lines right now, but we got something. Yes, day one in the books.
But for day one, that is really impressive. Most people are still learning how to make the Blender equivalent of the basic cube on their first day of CAD, so you should feel really good that you got this far in one day. In fact, I know some people in my graduating class of engineers that have not done anything as complex as that handlebar. So, good for you. Now, I'm going to jump ahead a little bit. He does consult with another guy who has done a 3D printed bike. His friend points out that his wheels aren't going to be super great with the way that he was currently designing them. Here we go.
This all looks like it's working well.
So he's printing the tire sections out of TPU, and he's using a dowel and socket connection for putting them together. So the tires being printed in 4 sections with a simple dowel between them, and the dowel is integrated into one of the pieces, so it's more like a peg, right? That does work, but it's not going to be the best connection. That's why I pulled up this video. This is another fantastic creator. Need It, Make It. This guy is squarely focused on engineering. But this video, adapting the best woodworking joints for 3D printing, is going to be a gold mine for coming up with good, strong connections for 3D printing. I love how when you click on something, though, in YouTube, it doesn't actually go straight to the frame that it showed you. So here he shows a sliding dovetail. Now, if you were woodworking, this would be kind of a nightmare to make. A dovetail at a acute angle like this. But for 3D printing, this actually works really, really well. And this alone would be a significant step up from the peg and hole connection that you have here. But you can even go crazier with it. If we jump to some of these connections further ahead, you can create some really complex geometry very easily in CAD, and these are going to result in much stronger connections for your 3D printed parts. So if anyone's looking at making their own connections like this, this is a great jumping off point for figuring out how to do that. And that would make this tire hold together a lot better. And that's going to be a theme that we see with the other parts, is they are all kind of held together with these dowels. And that's going to contribute to some of the weaknesses that show up in the final design. Okay, here we're trying to assemble for the first time the rim and tire. And for the rim pieces, he actually did use a dovetail. But we're going to learn something about PLA, which is what the frame pieces are printed with.
Oh my god, it works!
I love seeing how happy he is in some of these moments, though. I mean, this is the feeling
Dude,
of making something yourself.
That looks so good! And that's solid. That's not going anywhere. Oh!
And then it immediately cracked. Oh no! Okay. So PLA, not the right filament for this job. PLA is fantastic anytime you need something that is strong, rigid, and you don't care about temperature. All right, so the first demerit against PLA for making a bike is going to be temperature and UV stability. You're going to want something that resists the sun a lot better than PLA if you're going to make it into a bike. And so for that, I'd recommend something like PETG, but even better, ABS. And ABS is cool because you can actually solvent weld it very easily with acetone. So you can get a much stronger bond between two pieces of ABS than you can with just dovetailing them together like this, which is what we were doing earlier on the show, actually. Now, the other thing about PLA is it's extremely rigid and very brittle when it breaks. So, generally speaking, from a safety perspective, if something is going to break, you want it to break more gracefully, because that gives you a bit more of a warning so you can get people away from the thing that's about to fail before it causes damage. In this case, if you were going down the freeway on this bike and it suddenly fails and does so brittly and catastrophically like it would do, that's going to be you on the pavement. Whereas if it necks before it breaks, which is what ABS is more prone to do, then what would likely happen is the crash would be slower, causing less damage to you, but also giving you a chance to maybe even catch yourself. You know, it might be that the frame breaks in sections, and so you're able to kind of just land on your feet. You know, that would be the ideal scenario. The other thing that I don't want to say we've got wrong here, because this is Kev's first time doing anything like this, but one thing that could be better in the future is paying attention to print orientation. 3D prints are what we call anisotropic, meaning that they do not share the same properties in all three perpendicular directions. Not cardinal directions, I don't know what I was saying. your print is going to be much stronger along the XY plane than along any plane that involves Z. Okay? And so if you pay attention to how he has these parts oriented on the printer, we can see that leaves a bit to be desired. Most of these you're probably going to want to lay on their side. Now, the downside of that is it's going to require a lot of support to make a 3D printed bike frame. But you're making that choice between is it going to work or not versus the amount of support that you're going to be losing. So that is just one of the trade-offs you have to accept. He enlists several people to lend him their printers, which printing is not a super fast process. It does take some time.
We're near as good as Canyon's actual arrow. So Canyon, please don't sue me.
It's 6 a.m.
This scene is just
Jasmine
heartbreaking.
is working out, and she stopped me and told me that the Creality print failed. She described it as a big ball. Oh my goodness.
No!
That is catastrophic. Look at
That looks like it's about a kilogram of filament. It could be less. It could be more like... But I'd say it's at least 500 grams, right? I'd say it's between 500 to a full kilogram. Which just means that $10 to $20 just went out the door with that print. So it happens to all of us. Much less nowadays because a lot of printers are now shipping with cameras built in that do a really good job at catching fails like this. With this being a newer Creality, I am kind of surprised that it didn't catch it. But maybe it's not configured the way that I'm thinking it is. But I do know, like my SVO8, for instance, that I've been showing sneak peeks of on the channel, that does have built-in filament monitoring through Obico, and that has worked really good. So it really sucks, but this is also a loaner printer, so it's possible that he didn't have the same access to monitoring it like he does with the A1 that is his own printer, and that could also be contributing here. But happens to all of us. It really sucks when it does, but it's a lesson that hopefully you only learn once.
Creality's defense, I did not orient this, thinking about it now, in a way.
Okay, all right, so that's a good example. Let's see. Oh my gosh, why is it so hard to like find just the frame that I want?
In Creality's defense, I did not orient.
Oh man, that is like ninja reflexes. So about what I was saying with print orientation, this great example. This did contribute to it failing because anytime you have a large cantilever or an unsupported beam, which is what this is as soon as it leaves this joint, that is going to contribute to higher print failure rates, but that's not actually the part that I want to focus on. This part here that's laying on its side has a much better orientation from the perspective of strength than its buddy does here that's printed vertically. All the Z height layers are going to be cutting across this, which means that anywhere along this vertical section, it's going to be much more prone to catastrophic failure. Whereas this, you're getting much more of those long, uninterrupted layer lines, and those are going to be much stronger overall and contribute to a much more reliable frame. So, because you had the week-long deadline, that probably prevented you from being able to space these out more. But if you do a version 2, definitely want to take layer orientation into consideration and just take your time with it. Let things print the way that they are going to print with strength in mind. So lay them all a little flatter like this, and they'll be much stronger. And also, make sure you're using the right filament. Don't use PLA for something like this.
Thinking about it now in a way that was conducive to the print not failing.
So I'm going to jump ahead again. He has some more failures.
Look, again, the edges are lifting up, which means this print is going to fail. This is now becoming a problem, man, because that's twice that this piece has failed, and I don't know why. It's 10 hours now. It should have been done in printing something else.
Okay, so he has another print failure, and I'm going to spoil the ending here because I don't want to just rip off this guy's entire video. I do want you guys to go and watch it yourself. I mean, even though Kev clearly doesn't need my help, he's doing really well with these views. But he does successfully diagnose on his own why the A1 was failing, and it shows some real engineering prowess in being able to do that. What was causing it is this window up here was open as a means of venting the fumes out from these prints going on, and that was allowing cold air to come in through the window and fall down onto the printer. And that temperature differential was making it so that the A1 just wasn't able to compensate for those fluctuations, and that was causing it to lift up. So closing the window, moving the printer to a different location, A1 was back in business. Now, from the perspective of printer design, that's why a lot of newer printers are coming with enclosures built in. A good example is the Creality that he has there with him as well. And I think by this point he's also acquired another friend's X1C. But the great thing about an enclosure is it eliminates those kinds of fluctuations across the board for the most part. Right? You still need to do some work and monitor it yourself, but that's going to be one of the major benefits of an enclosed printer, is that it's much less sensitive to the temperature fluctuations of its environment. But again, good on you, Kev, for successfully figuring that out. That's something that trips up a lot of new printers, and didn't stop you, man. Now, this is probably, actually, no, I want to jump back and take a look at the wheel design that he was working on. Now, this is probably where I would advise you that not relying solely on 3D printed parts is going to be your best route. Now, I know we're trying to make a Canyon Arrow at a discount, but that technically means that anything less than $6,500 is going to be money in our pocket, right? A big problem that you're going to have, particularly with a wheel like this, is your printer's not going to be able to hold the same kinds of tolerances that you would get with a professionally machined metal bearing hub and rim and rim spokes. So if let's see, got to pull out Photoshop. Ba-na-na-na. Oh, that's way too small. No one's going to be able to see that. All right, so what we've got here is a rear view of the wheel hub and how it connects to the frame. With professionally machined parts, this gap right here can be much smaller, where with a 3D printed part, it's going to be significantly bigger, just because you can't meet the same level of tolerances, so you're going to have to give it more space to be able to do its thing. What that means is if you apply a sideways load, for instance, you're pedaling or you take a turn, anything that causes the weight to shift at all, that's going to create a moment where your center of gravity is somewhere up here and that's moving, say, to the left, right? That means that we've created a moment arm across the middle of our rod here, where the frame is going to want to move like this, and the wheel is going to want to resist that because it's being held to the ground by the ground, right? So it's got the spokes that connect it to the ground. It's going to have an opposite force moving it in that direction, which means that we have a lot of force right here and right here, right on our 3D printed hub. And that's, as you can see in this design, that's going to be one of the skinniest sections of this 3D printed wheel, which means that it's going to have even less support to resist those forces. So if you do a version 2, what I would highly recommend is just getting some professionally manufactured wheels and using those instead, because what that will allow you to do is it eliminates a lot of variables that you no longer have to think about with the construction of the wheel itself, the bearings, the axle. All you have to do is focus on making a frame that mates to it in a satisfactory way. And because you're using a machined part, what you could even do is you could just use the axle itself to drive its own threads through your 3D printed frame. And that's going to be a much more solid connection than what you're able to achieve with purely 3D printed parts. And I would say the same goes for the all those twisty bits going through the head tube. Like, you probably just want to put a properly machined bearing in the head of the frame, and same thing goes for your pedal crank arms and the pedals. Like, it's okay to use some off-the-shelf parts. That's going to get you much closer to having a 3D printed bike than a bike that just won't be able to exist on its own. Like, even in the guy that he talks to, if you look at that guy's bike, it's still using a lot of off-the-shelf metal hardware to make it possible. Otherwise, you're going to have to divert in a very big way from what the Canyon Aero is. All right, let's jump back to where we were. Ish. Even just getting all this stuff printed in a week is pretty cool. This guy was really just cruising along to make this happen. But he's got 3D printed single gear crank arms. I've already talked about those. I don't think that's a good idea. Same goes for the rear hub. But the fact that you designed all this in a week with no prior experience is, again, really, really impressive. Now, the other thing that I want to talk about here, though, is if you're willing to go a little further from what a 3D printed bike would be, you can use this frame as a core, and you can do a carbon fiber layup around it. And that would give you a much stronger frame overall, but that might be going a little too far off what we consider a 3D printed bike to be. So I understand if you don't want to do something like that, but it would be a really cool way to make your own carbon fiber bike with minimal expenses by just 3D printing a core and then doing a layup around it. So that could be a video topic all on its own. Maybe that's something I should do. Never mind. I take that idea back. I'm going to do that myself. But again, 3D print orientation makes a big difference. You can see how a lot of these were printed vertically, and it's just not going to help. Then we have some tragedies along the way of assembling this. He even made a TPU printed chain, which is kind of insane. Not a very great idea. I don't see that working very well. But it is cool that he tried it.
The bike is officially completely printed. Let's put this bike together. Oh. Look how badly that broke.
Yeah, man.
Yo, this is working out so well. Lord, thank you so much for this opportunity. Nice.
Again, I really recommend you go and watch this guy's video in full. As you can tell, he just exudes enthusiasm and charisma. It's something that I need to learn from as a creator. He does a really good job of presenting this. All the ups and downs. I had a great time watching it the first time, and it's just bringing a smile to my face again watching it with you guys.
Oh, no. I was done at this point.
PLA, man. PLA and print orientation. Oh, and tolerance. That's the other thing. You can't make things to be exactly the same size and have them work out in real life. What I did with the Constellation parts that we were working with before in the show is I gave those a 0.13 millimeter offset for the bow ties to make it so that those bow ties could actually snap in. That's because when you print something, it's going to shrink naturally, and so you need to plan as best you can for that as well. Otherwise, you're going to end up with situations like this where things just are not going to fit together.
It had been 6 hours of this. The frame had a bunch of cracks, one wheel was destroyed, and I knew the other would do the same, so I quit. I called my wife and my family and told them that the bike was breaking and there was nothing else that I could do. So my goal of riding my dream bike on my birthday was a failure. But I guess I just needed a little break, because after about 2 hours, I came back to my senses and realized there's no room for the tire to spin. Dude.
And that's another engineering lesson. Your first prototype is never going to be your last prototype. So I wish I could say it gets easier, but I'm still finding that I'm making really dumb mistakes like this all the time. We're working on the air guns that I do. You miss one dimension or you forget to change it, and then it shows up in your printed prototype and it's like, oh yeah, okay. Well, I guess that's why V2, V3, V4, V69, that's why all those exist, is because you're always going to miss something.
Engineering a bike is freaking hard, man. How did our imaginary non-measurements work? Oh, yo, that's so perfect.
And that's almost a more dangerous scenario, is when something does happen to work the first time. There's some lessons that maybe you didn't get to learn along the way. And so you should always try and do a retrospective anyways and see, this didn't go wrong, but how could it have gone wrong? And still just try and see if there's some wisdom you can glean that way.
Oh! Get out of here!
But it spins.
The back wheel spins, baby! Yeah!
I mean,
I'm glad I finished putting it together.
Really pretty cool.
What? Damn, that's so cool! I made this! Bike assembled! Ish. Even though this bike was broken everywhere, I still wanted to see if it can support some weight and I can ride it. Oh! No. So here's the bike. 6 cracks in the wheels, 5 cracks in the frame, no way to hold your seat, no chain, a front wheel that doesn't spin, and handlebars you can't trust, but I made this! We made this! I think we all know how this is gonna end, but we all wanted to see the bike break. Let's just do it.
That's too tall for me. I can't.
Thank you, baby. 3, 2, 1. That was amazing.
All right, so that's the last of the video that I'm going to share because you guys really need to go watch it yourself. We saw a brief snippet of his wife there. These guys are relationship goals. I don't want to spoil it. You're just going to have to go and watch the video yourself, find out what I'm talking about. But she is really sweet in this video, and I hope we can all find someone who takes care of us like she does. But now, with breaking the bike, imagine doing that going 25 miles an hour on a busy street. That's why you don't want to use PLA. It's still probably going to hurt when it breaks and it's made out of ABS, but we're going to have a much better chance of getting a functional bike out of something more robust than PLA. But that has been this first installment of An Engineer Reacts. I hope you enjoyed it. And make sure you like, share, comment, subscribe. Do all the YouTube things. Let me know what you think down in the comments below. And allow me to continue stalling while I find this button. There we go. Like, share, comment, subscribe. Do all the YouTube things. And special shout out to the channel members. Your support makes my content making career possible. So it helps. It's the best way to directly support the channel, and I can't do it without you guys. So if you want to see more stuff like this, you know what to do. But with that, this is Odd Job Entertainment signing off, but not for the stream. This is part of a larger stream, so you could go and watch that too. But I just want to make sure that people who are watching me currently know that once the outro's finished playing, I'm still going to be online, so don't go anywhere.